everybody. I am Professor Caudill, AI2C, and picking up where we left off with vectors. So, vector x component, remember last time the I hat is our I hat is our x vector, our x unit vector. So he's showing this trick where it's a negative 4 I hat. You can rewrite that as 4 negative I hat. Then the displacement is 4 times absolute value of I hat. 4, because I hat's always 1. So you see, even if I hat was a negative, it would still be 4. Now if it was a negative I hat and negative 4, then that would be 4 as well. Parallel to the y-axis. Okay. I think I've already done this one. I recall being here. Talks about the inverse tangent. So you take the Pythagoras theorem of the magnitude. You take the Pythagorean theorem of the magnitude of the components to get the magnitude of the whole vector. So you got this unit vector, you got this unit vector. So when you add, so if this is 4 and this is 4, then that's 4 squared plus 4 squared equals 32. So you're going to get a vector that's 32 because there's a right angle here. Drop this down, there's a right angle here. And we know the length of this, and we know the length of this. This is equal. So, pretty self-explanatory, I would say. Probably the harder one is taking the tangent. So if you know, if we want to know theta here, okay, so tan theta is TOA opposite 4 over adjacent 4. So it's going to be theta equals the inverse tangent of 1 in my example. Now, probably faster just to, so tangents, inverse tangent, it's also called the arctan, is atan equal to tan, yes, tans, the result is the same. So if you want to use this in SymPy to actually calculate the value, this is a way to do it. So I didn't know there's an ATN2. So if you have the denominator 0, this should be good for most things. One thing I'm wondering about is if there's like a shorthand, like a way to estimate the inverse tan. Um, that might be interesting. So let's take a shot at this. So D is 5 negative I hat plus 3 negative J hat. Okay, find its magnitude and direction. So magnitude of the x direction is going to be 5 times negative 1. And then the same thing for the x. So dy is going to be 3. This is going to be 5. So magnitude of this vector d is going to be d without an arrow. It's going to be 5 squared plus 3 squared, 25 plus 9. In many applications, magnitude and directions are known. We need to find the resultant of many vectors. So what is a resultant? I know the book told me, but let's get a second opinion. What is a resultant in vector map? So it's a sum or net effect of two vectors. So imagine 400 cars moving on the Golden Gate Bridge. So if you have a bunch of cars on the road, on a bridge, each one has a down vector. So you want to sum all of these vectors from n 1, 2, 3, 4, 5, 6, 7. So I guess I could say 1 to 7 of vector n. So you'll be doing that. So this would be the magnitude of each vector. Notice I'm not putting an arrow here. So very first step in analytic approach is to find the vector components when the direction and magnitude are known. Figure 2.8, 2.18. So let's return to this. Hold this in your mind. So this is basically saying, so opposite over hypotenuse, adjacent over hypotenuse, quotient of the adjacent side. So well, we want to know this angle theta. And This is our AX. And A is the hypotenuse. So we're not calculating anything, we're just kind of, this is an abstract representation. So you can find theta, where you can find if you want to find the adjacent side. So if, okay, so if A and AX are known, then you can do adjacent over hypotenuse. So you can say cosine theta equals AX over A, and likewise, if AY and A are known, then sine theta is opposite. So AY, because this y-axis can translate to here, over A. And this is verified over here. And this can operate with the reverse. So let's say we don't know AY, but we know A and theta, then we can find the components via A sine theta equals AY. So if A and theta are known, then we can find this just by plugging in these numbers. And I think that would be in radians. If I is A sine theta equals A y, and A y is unknown, will A y be in radians? My bad. Would theta be input as radians? I mean, I know you can do 180 over pi to convert it. Expected to be in radians. Yep. I got this backwards. Pi over 180. If you want to convert degrees to radians. So degrees, theta in degrees to theta in radians, then you do theta degrees times pi over 180. Theta radians. Calculating vector component. Care must be taken with angle, direction. Theta, the angle must be measured clockwise from the position, direction of the x-axis. The clockwise measurement gives a negative angle. Okay, so this is important to know. Okay, so rescue party, missing child, looking for dog, trooper. Trooper finds a child. Sorry, it's happy. Okay, so southeast. So we want a unit vector for southeast. So southeast is going this way. So if we had that's that's going to be 1 in the x direction, -1 in the y direction. So we're going to say u hat is, let's make it easier, southeast hat is going to be 1, -1. Then he runs north, so our north hat is going to be 0, 1. Then it goes 30 degrees north, 30 degrees west of north. So how will we write this one? That is tricky. So we're going to say 30 degrees west of north. So 30 degrees. I'm just gonna write multiplied by north. That might not make the most sense, but it might be useful for just spelling it out. Fourth leg, troop goes directly south, so south hat. Okay, so find the scalar components of Trooper's displacement vectors and his displacement vectors in the vector component form for each leg. Okay, so his initial position is going to be 0, 0. Starting at 0. Move 1 is going to be 200 southeast plus P naught. Initial position, I know it's redundant, but it should be noted. Okay. Move 2, he's going 300 north hat plus M1. M2, he's going, I'm sorry, M3. He goes 50 meters, 30 degrees of north. And then he goes M4 is 80 meters times 23. Okay, so um, then the last move is 150 meters times 23. Okay, so I've already shorthanded this, so southwest plus M, and this should have been 30 degrees north, should have been I hat, but get the point. Okay. Okay, so do I have an eraser? Okay, the eraser doesn't work. Alright, my bad. So let's draw this out. So southeast. It's going southeast. M2, he's going north. Okay. M3, he's going 30 degrees of north, so he's going so if this is north, he is going 30 degrees. Let me make this a little bigger for you. M3. So if this is north, he's going 30 degrees. And this is 50. Okay. And this would be negative 30 degrees, wouldn't it? Because clockwise measurement gives a negative angle. So I think it would be negative 30 degrees. So find the scalar components of troopers' displacement vectors. So like displace will be easy, that's just 200. Um, you would just add all these up. And we would get a number. It's not, I don't think it's necessarily asking me to compute this vector. I guess it does want me to find this component. So what is this asking? So we know the hypotenuse. So we know h is 50, theta is negative 30. Okay. We want to know the adjacent. So we're looking for O. No. We are looking for adjacent over hypotenuse. So we want to get the opposite. So this is going to be, we want to find this dx. We have dy. dy is 300. So this is 300, right? So I guess we won't even need trig, right? Because if this is 300, then it's 50 squared equals 300 squared plus b squared. So it's going to be 50 squared minus equals our dx magnitude and magnitudes are absolute values, right? So it's the absolute value of this. So 50 squared, that is 5 times 10 to the 1 squared. So 225. Is that right? 50 squared. 2500. Okay, so we are right. 3 times 10 to the 4. It's 30,000. It's 30,000. So we want the square root of 2,500. So it's going to be, no, it's going to be negative 2. So you can't take a square root of a negative number. So maybe the absolute value is on the inside. Pretty sure this is no. Yeah. So we're gonna note this down and we're gonna look at what the book's doing. So I guess there's different ways you could do it. Um, you can either, if you have a mix of like quantities for directions, so kind of comes down to how do you want it? Do you want it in polar coordinates? That might be the right term. Or do you want it in Cartesian? So the book seems to go with the polar coordinates. So southeast, it's saying, so let me, okay, so south east is this way. So if this is the x-axis, measuring here, that's 180 degrees. Here, that's 90 degrees. So you're at 270 degrees. So whatever this is, that's 45 degrees, right? So it's going to be 270 plus 45. Is that what he got? Yes. So 315 degrees. So he's basically saying southeast is 315 degrees. So he's saying So we're saying the first move the x of the first move, so the magnitude of the first move's x component. If we go up to the book, we would call, he goes 200 meters southwest. So 200 meters. So we want to know the x. So we want to know this distance. So if you know the angle, so the angle is 315. So the direction's 315. So that's like our I hat. So in a way, our I hat is, I don't know if that makes totally sense, but say our C hat is cosine theta. It's maybe one way to think of it. So we're doing 200 times cosine of 315. So you might be wondering, why am I taking so long? It's because I'm trying to understand the trig. That's one of the, like, I never took trig in high school. I kind of just bulwarked through calculus, so I don't have the greatest trig intuition. So I'm trying to understand um, how this is working. So it's saying 200 times this direction is your x component. See, so cosine. Why are you taking cosine? So cosine is cos. So you're taking the adjacent, which is this. Adjacent over hypotenuse. So we're trying to find the adjacent. So the formula they're using is the hypotenuse times the cosine equals the adjacent. So this is why I've been taking so long on this, because I had to see this. This might be quick for some people, but this is what I had to kind of take a moment on. So this is this. Mx is your adjacent. Okay. So now you want this. So So 200 sine 315 equals m, the y component of our first move, which is going to be this. Okay. So a vector going southwest is going to be 200 at 315 degrees with a y component of and a x component of 200 cosine 315, and these should be converted into radians. So it's really saying, when the book is saying L1x equals L2 cosine theta 1 equals 200 cosine 315, it's really saying 200 cosine 315 pi over 180, because we want to convert this into radians. So to verify, I will show you times cosine 315. So 133. So they're getting 141. So that's a little weird. Times pi over 180. I think the calculator does it automatically, but I guess it's good for intuition to know. Oh, so there, that fixes it. So yeah, so the calculator was already reading this as radians. So that's an important thing you might have missed if you were using SimPy and you didn't know this, because you actually would have got the wrong answer. So yes, 142, 141, 141 meters in the east direction. So what am I gonna say? E hat, where E hat, where E hat equals 1, 0. I mean, it's not necessary, but you really want to be specific because vectors have a direction and a magnitude. I guess this isn't a vector either. This is the magnitude. So you don't actually need this either. Okay, so it makes sense. Again, the book kind of, you just have to be careful with the radians. So one thing I had trouble with is just kind of conceptualizing this whole thing, this whole turn as a degree. Like, this is a 315-degree turn. It's hard to conceptualize the SOHCAHTOA in that form. It might make more sense to think of it like, okay, this angle is 45 degrees. 360 minus 45 equals 3. So 5, 315. So I mean, I guess you could say this is negative 45, right? So I don't really get why. So over here it says the direction of angle theta is measured counterclockwise from the position that the clockwise measurement gives a negative angle. So it's saying this is negative 315, and then this would be positive 45. But then when it writes it down, it's giving positive values. So I don't really understand what the book's saying. I wonder if that messes up the calculation. So it doesn't. So if you had a negative sign here, that'd still be correct. And what if it was sine? This should be negative. It's not negative. So I don't know what's going on here with the book. Okay, there it goes. Yeah, so these numbers match up. Book's not too bad. It's just if you want, if you took negative 315, you get the same as sine. No, it's not right. If you use a negative degree, you get a slightly different answer than what the book gives. So I think the book might be wrong here. If you're using positive, then you get the book's answer, but according to the book, it's supposed to be negative angles. Clockwise measurement is given as a negative angle. If I go 315, one, two, 2, 3, 2, 4. Is that angle supposed to be expressed as negative 315 degrees? We go counterclockwise, moving in positive direction. In this case, we're indeed going. If you were to move clockwise, it would be a negative angle. Okay. So you could go plus 315, or you could go negative 45. Okay, so this is directly counter to the book, isn't it? So is the textbook wrong in saying so if you're measuring an angle counterclockwise, it's positive. Okay, so clockwise, negative. Okay, so I get this. So I think I just misread this part. This part stood out, and I think I just misread it. So yeah, so it's positive. So this would be positive. So, okay, so in theory, I should be able to write negative 45 degrees. That should be 148.1. Okay, and if I change this to sine, it'd be negative. Okay, so there kind of, I just kind of cleared everything up. So, hope you don't mind me spending time on that. So my approach to this problem was very analytical, and it's hard to do the mixed, a hybrid. So I guess a book does make it easier by combining it. So north is 90 degrees. So he's saying you're going north 300. So the x component is going to be 0. The x component 0. And you're going 300. So it does kind of start to make sense. You're taking a vector, and this vector is the resultant of the magnitude of its components times some direction vector. And then, and this direction vector can be either something like this, or it can be something like this. And then you're taking it times the magnitude of the y times another direction vector, which is the same as saying I think that's equivalent. Um, so yeah, J, this gets canceled out because it's a 0, the I. So yes, and that's in meters. Okay, so let's try this. If he runs 20 meters west, 20 meters. So what's his displacement vector? So this move is going to be the magnitude of the x times I hat plus magnitude of the y times a j hat. So the magnitude of the x is so if it would be like this, 180. So m is would be negative 200, would be negative 20. I don't think so. I think it would just be 20 in this direction. So instead of thinking like SOHCAHTOA, what pattern is the book using? If you see the pattern, the x component seems to be with the cosine, the y with the sine. So instead of just trying to visualize the triangles and And the adjacent angles, I'm just gonna copy the book's the pattern the book's using. So I'm going to guess this is going to be cosine of pi. Okay. Why pi? Because it's going to be cosine of 180 degrees. We'll say pi radians for clarification. So it's going to be 180 times pi over 180. 180s cancel. Pi radians. Plus the y component, which is 0. Sine. I don't know. Is it the same angle? I think it's the same angle. So 0 times, well, it doesn't matter. It's 0 times it, but I just wanna kind of scared. I'm gonna say pi radians as well. I know it's gonna be 0 either way, but so m is so we're say 20 times cosine 20 times pi. So it'll be 20 I think this would be the magnitude of this whole vector. So m is 20 plus 0. I mean, pretty trivial, but I'm just wondering how well this pattern holds true. Seems to hold true for all x components. So x cosine. Y is sine. Is there a memorization rule of thumb to remember the x the x axis what's it called when it's a piece of a vector? What's it called? Components. X-axis components. Is there a memorization rule of thumb to remember the x-axis component goes with the cosine function and the y-axis component goes with the sine. What is this? It actually gave me something? Okay. For vector mathematics, the mnemonic is often the phrase all students take calculus. How? What's A? This mnemonic helps you remember the context of right triangles. The sine of an angle. Try again. Think outside the box and try again. C for X. cosine for x. C, the C shape resembles the x-axis. What? Okay, yeah. C, x-axis. I don't think so. S shape resembles the y-axis. Okay, so maybe you could say it like this: sine, since S is kind of like a vertical sinusoid, then you could say the y component is sine of the, because the y-axis is kind of like this shape, and sine S is like this. Okay, so maybe that'll work. All right, thank you guys.